So let's consider the following expressions that contains SATs. Let's say we have x plus 2 divided by square root of x, let's say plus 5. And we have another expression. Let's say we have it as x minus 1 divided by, let's say, the square root of x. Let me have it in this way. Let's say have x plus 2, and on top we have, let's say, should be square root of x minus 1. So in the first actually expression, we have a radical, or we have what we call as a SAD on the denominator, and in the second expression we have a SAD on the numerator. So what is the process of removing the SAD on the denominator called as? So the process of removing a SAD, we call it as a rationalization. We call it as rationalization. And if the SAD which is being removed, it is the one on the denominator, we call it as rationalizing the denominator. And if the SAD which is being removed, it is the one on the numerator, then it is said to be rationalizing the numerator. So that's the principle behind. So this video I want to discuss about the rationalization, where specifically we'll be actually removing the SADs, either the denominator or the actual numerator, like that. But how do we actually remove, or how do we rationalize the actual denominator or the numerator? So we should have to understand about what we call as the conjugate. So we should have to understand about the word conjugate. Now if we say a conjugate, this is the reciprocal form of a something. That is said to be the conjugate. It is the reciprocal form, or the reciprocal representation of an entity or of a something. That is what we call it as the conjugate. Or in a simple way, we can call it as, the reverse of something, or the opposite of something. That is actually a conjugate. And let's say we have the square root of x. So the conjugate of the square root of x is the same as the square root of x. And the conjugate of x plus, let's say, 2, it is the same as the x, square root of x plus 2. While the conjugate of x plus 2, this is the same as, the conjugate is given as the square root of x minus 2. And if we have, let's say, x plus the square root of 5, like that, and the conjugate of this one is given as x minus the square root of 5. And we have, let's say, x minus the square root of, let's say, 6x. The conjugate of this one is given as x plus the square root of 6x. And let's say if we have something like this, let's say if we have the square root of 5x, let's say, minus the square root of x plus 5, the conjugate of this one is given as, square root of x should be 5x plus the square root of x plus 5. In other words, the signs inside the actually a SAD, they are not affected. In other words, the signs inside the square root or the radical, they do not change. So keep that in mind. And also another thing you should have to understand about the rationalization is that if we have, let's say, the square root of, let's say, let me have this one. If we have, let's say, nth root of x, and let's say times the nth root of, let's say, x. Since these actually roots are of the same carrier, then this is the same as having it as the nth root of x times x, which is the same as the nth root of x squared. In other words, if we have, let's say, the square root of 5 times the square root of 5, this is the same as having it as the square root of 5 to the power 2. Rather should be square root of 5 times 5, which is the same as the square root of 25. So that is the same as that. And we can also have something like this. Let's say if we have, let's say, the cube root of, let's say, 6 times the cube root of, let's say, 7. This is the same as having it as the cube root of 6 times 7. So that will be given as this cube root of 42. So you should have to understand that one. And if we have, let's say, the square of, and that should be x times the square of x, this is the same as having it as the square of x squared, of which this is the same as having it as x. So in other words, if we have, let's say, nth root of x to the power n, this is the same as having it as x, since the power of this x and the carrier of the root all becomes the same. So in that case, the root will vanish out. We just have x there. So keep that in mind. Now let us see how we can rationalize the actually denominator for this. Now, in order to eliminate actually this a radical or the shadow in the denominator, here the process. You just have to understand that we have x plus 2 and divided by the square of x and the plus 5. So you just have to understand that having this expression, it is the same as having it as, times 1 over 1. So it is the same as that. And generally speaking, if we have m over n, this is the same as having m over n, times 1 over 1. It is the same as that. Then how should we have to replace actually those ones with? We should have to express this with the conjugate of the actually denominator. So which means we have x plus 2 and divided by the square of x plus 5 and the times square of x minus 5 divided by the square of x minus 5. We'll have that. So now in this case we'll have to multiply this and this like that. So have x plus 2 times square of x minus 5 divide by, so have the square of x plus 5 and times square of x minus 5. We'll have that. Then in this case, we'll have it as, let me just have to take this out. So now we'll have it as, we can think of, now we should have to expand here. So have x times x squared, it should be x times x cubed, should be x times the square of x. This is the same as x times the square of x. We should just have to leave it in that way. Then minus x actually times negative 5, that is negative 5x. And we'll have 2 times the square of x, that is plus 2 square of x. We have 2 times negative 5, we have it as the negative 10. And that which is divided by, have x times, should be square of x times x. Square of x times square of x. It is the same as having it as, and that is x. And the square of x times negative 5, we have it as negative 5 times the square of x. And 5 times positive should be positive 5 times square root of x. It is the same as the positive 5 square root of x. And positive 5 times negative 5, we have it as negative 25. So in this case, we have it as x times the square root of x, and then minus 5x, and that should be plus 2 times the square root of x minus 10, which is divided by. In this case, this and this will go since they are actually like terms. So have x minus 25. So in that way, we cannot actually simplify these. They are like terms. So that will be, this is the solution. So that is how you should have to understand. And later you can see that on the denominator, the radical has been actually eliminated. And how about the other case there? How should we have this? Principle remains the same. Having this kind of expression, this is the same as having it as the square root of x minus 1 over x plus 2 times 1 over 1. In this case, what is the conjugate of square root of x minus 1? This is the same as having it as the square root of x minus 1 over x plus 2, and it times the square root of x plus 1 over the square root of x plus 1. So in that case, we'll have a square root of x times square root of x, which is given as x. And negative, actually, a square root of x times positive 1 will have a positive square root of x. And negative 1 times square root of x, we have negative square root of x. And negative 1 times positive 1, we have it as negative 1. And which is divided by x plus 2, times the square root of x, plus 1. And this will go, we'll just have it as x minus 1 divided by x plus 2, and it times the square root of x plus 1. So we just have to leave it in this way. So this is the solution. So those are the principles behind rationalizing the denominator or the numerator. Always, it is specified how you should have it. Either you have to rationalize the numerator or the denominator. And let's say we have this kind of a case. We have, let's say, it actually should be 4, and that plus the square root of 5, and that divide by, let's say, the square root of 3. That should be minus, let's say, the square root of 2. Now, how should you have to rationalize let's think of rationalizing the denominator. So in this case, the principle remains the same. We'll have 4 plus the square root of 5, divided by the square root of 3 minus square root of 2. Which is times, what is the conjugate of this? Have the square root of, should be 3 plus the square root of 2, divided by the square root of 3, and plus the square root of 2. And from there we'll have 4 plus the square root of 5, that is times the square root of 3, plus the square root of 2. Like that, divided by. So what is the square root of 3 times the square root of 3? We have it as 3. And square root of 3 times the square root of 2, let's just have to express it as plus the square root of, that should be 3 times the square root of 2, and the negative square root of 2 times square root of 3. This is the same as negative square root of 2 times the square root of 3, and the negative square root of 2 times the square root of 2 as a positive will have negative 2. This and this will go. What we'll have is x should be 4 plus, the other should be 4, plus the square root of 5, and the times will have a square root of 3, plus the square root of 2 divided by what we have it as 3 minus 2, which is 1. So the solution is that one on top. So that is how you should have to get it as to rationalize. So try to have the following at your own time. You should have to rationalize the denominators. We have, let's say, 2 over 4 plus the square root of x. That one. And also try it as 2 minus the square root of 3. Divide by 8 minus the square root of 3. and let's say we have something like, let's say 5 minus the square root of 4 divided by the square root of x plus 2, minus the square root of x plus 5. Try to rationalize the denominator in that way. So this is how you should have to get it on the actually rationalization. Now, and also let's try the following questions. Let's say we have the square root of 2 is given as, let's say, 1.414, and we have the square root of 3 is given as, let's say, 1.722, and let's say the square root of 5 has been expressed as 2.2, let's say 36. The question says that we should do rationalize the following and simplify with respect to the given actually parameters here. Let's say 1, we have 3 times the square root of 2. Let me have it proper here. So 3 times the square root of 2 and divide by, let's say, 2 times the square root of 5. So we should have to rationalize the denominator, and then we should simplify with actually these given parameters to 2 decimal places. So try to have that. And also we should have to have this. Let's say we have 3 square root of 2 divided by, let's say, square root of 20. And also in the same way we have, let's say, the square root of 45 and plus the square root of, let's say, 50, that divide by square root of 48, and that should be minus square root of 18. So how do you think you can have that? And let's say we have also this other case, square root of 3 and minus the square root of 2, and which is divided by the square root of 3 and plus the square root of 2. So how should you have to have that? In all cases, you should have to rationalize the denominator, then simplify. And now we also have this case as well. Let's say we have x being given as, let's say, square root of 5, and now we have y being given as, let's say, square root of 7. Now we should have to express the following in terms of x as well as the y, and we have, let's say, the square root of 1260, that one, and plus 2 times the square root of 5, and the 2 we have, let's say, square root of 112 and minus the square root of 20, and which is divided by square root of 140 minus 5. And also we should have the square root of 140 minus the square root of, and that should be 45. And we also have this case, which is the square root of, let me just have to stop it here, but try to express this the way it is there. So for this case, no need of rationalizing. So thank you.